Room was silent. No celebration, no smiles, only tired faces and empty coffee cups. Outside, the world had already decided something important. Most people believed this dream was over. In a small office in California, a group of engineers sat quietly. They were not famous, they were not rich, they were scared. This was SpaceX, and this was the moment when everything was about to end. For decades, space travel had followed the same old path. Big governments, big budgets, very slow progress. Rockets were powerful, but they were also wasteful. Each launch cost hundreds of millions of dollars, and after one flight, the rocket was destroyed, burned, lost, gone forever. Experts said this was normal. They said space was expensive. They said nothing could change that, and everyone believed them. But one company did not. SpaceX believed rockets could be different. They believed rockets could come back. They believed space should not be only for governments. This belief was dangerous, because when you try to change something old, the world pushes back hard. SpaceX was not born strong. In the beginning, it had no history, no trust, no support from experts, only a small team and a very risky idea. They wanted to build a simple rocket, a cheap rocket, a rocket that could one day be reused. Many people laughed. They said, rockets are not airplanes. They said, this will never work. They said they will fail. And at first they were right. The early launches were painful. The rockets did not reach space. They fell into the ocean. They exploded in the sky. Each failure cost money. Each failure cost time. Each failure brought SpaceX closer to the end, but failure was not the worst part. The worst part was silence. No investors calling, no new support, only questions. How long can this last? How much money is left? What happens if the next launch fails? No one had answers. By the time SpaceX reached its third launch attempt, the situation was critical. Money was almost gone. The team was exhausted. Pressure was everywhere. Some engineers had not seen their families in weeks. Others slept in the office. They believed in the mission, but belief does not pay bills, and belief cannot stop a company from dying. Then came the third failure. Another rocket lost. Another explosion. Another headline saying SpaceX was finished. Outside the company, people said it was over. Inside the company, people were afraid to say it out loud, but everyone felt it. This was not just about one company anymore. If SpaceX failed, it would prove something dangerous. It would prove that private space companies could not survive. It would prove that space belonged only to governments, and the old system would remain forever. Expensive, slow, unchanged. The team gathered again. This time, the silence felt heavier. There was only enough money for one more launch. If it failed, SpaceX would shut down. No second chances, no backup plan. This was the final shot, but before that launch could happen, something unexpected occurred. A phone rang. It was not loud, it was not dramatic, but it would change everything. The call came from NASA. Yes, that NASA. The same organization that had trusted only big companies for decades. The same organization that had watched SpaceX fail again and again. Now they were calling. NASA had a problem. They needed a new way to send cargo to space. They needed innovation, they needed lower costs, and strangely SpaceX was still on their list, but NASA had doubts, many doubts, so they made a call not to promise help, not to celebrate success, but to ask one simple question: can you do it? For SpaceX, this call was confusing. They were almost out of money, almost out of time. Yet NASA was asking if they could deliver. It felt unreal, hope mixed with fear, because if SpaceX said yes and failed again, the damage would be permanent. Inside the company, discussions started immediately. Some said it was too risky. Others said this was the only chance. The decision was heavy. If they refused, SpaceX would likely die quietly. If they accepted and failed, SpaceX would die loudly. There was another option: to try. The leadership looked at the team, tired faces, broken confidence. But still something was there: determination. These engineers did not join SpaceX for safety. They joined for change, and change never comes without risk. SpaceX answered the call. They said yes, not because they were ready, not because success was guaranteed, but because this was why SpaceX existed, to try when others would not. The pressure increased instantly. Now, failure was not just personal, it was public. NASA was watching, the world was watching, and SpaceX had one last rocket. The team returned to work with new urgency. Every bolt mattered, every wire mattered, every decision mattered. There was no room for ego, no room for mistakes, only focus. This rocket had to work, it had to fly, it had to survive, it had to reach orbit. And most importantly, it had to prove that SpaceX was not crazy. Late nights became normal again. Engineers checked systems again and again. They argued, they tested, they fixed. Fear was always present, but so was hope. Outside the building, few people noticed. The media had already moved on. The public had already judged. But inside SpaceX, something was changing. The desperate call had given them purpose. One final chance to prove everyone wrong. The launch day was approaching. Weather reports were checked constantly. Every delay felt like torture, because time was the enemy. Money was disappearing, patience was disappearing. This launch could not wait forever. On the night before launch, many could not sleep. They knew what was at stake, not just jobs, not just a company, but a new future for space travel. As the rocket stood on the launch pad, silent and tall, no one knew what would happen next. Success or failure, hope or collapse, history or forgetfulness. And as the countdown began, one thought echoed in every mind: this is it. The night was unusually quiet, no cameras, no reporters, no applause, just a rocket standing alone. This was not a celebration launch. This was a survival launch. For SpaceX, there was no tomorrow. Inside the control room, people whispered instead of talking. Every screen showed numbers. Every number could decide their future. They were not dreaming anymore, they were counting seconds. For most rocket companies, a launch was routine. For SpaceX, this launch was different. This rocket was not just carrying fuel and metal, it was carrying hope, it was carrying the last chance. If it failed, SpaceX would disappear. No headlines, no second chances, just silence. Many people outside the company did not even know this launch was happening. They had already decided SpaceX was finished. 3 failures were enough proof. Experts had spoken. The internet had laughed. Investors had walked away. Why watch a 4th failure? But inside SpaceX, no one was laughing. Fear was everywhere, not loud fear, quiet fear, the kind that sits in your chest and does not move. Some engineers remembered the first day they joined SpaceX. They remembered the excitement, the belief. They wanted to change space forever. Now they just wanted the rocket to fly. The countdown started. 10 minutes. Someone checked the engine data again. Everything looked normal. Too normal, that made it scarier. Space is unforgiving. One small mistake is enough. One wrong signal, one loose connection, and everything ends. 5 minutes. No one spoke. Eyes moved between screens. Breathing slowed. 4 minutes. Fuel was flowing. Cold, dangerous. Any leak could turn the rocket into fire. 3 minutes. Someone swallowed hard. They had seen this moment before, and it had ended badly. 2 minutes. The rocket stood still. But inside it, power was building. Pressure was rising. 1 minute. This was the point of no return. If something went wrong now, they could not stop it. 30 seconds. The control room felt smaller. Time felt slower. 10, 9, 8. At 0, the engines ignited. Fire exploded under the rocket. The ground shook. For a moment, no one breathed. The rocket did not move. That second felt endless. Then it rose, slowly, carefully. The room froze. This was new. This was different. Rocket climbed higher. Still straight, still stable. No explosion, no sudden failure. People leaned forward, afraid to hope. 30 seconds into flight, still flying. 1 minute, still flying. This was already better than before, but space is patient. It waits. The rocket passed the point where the first failure had happened. Then the second, then the third. Each second felt unreal. 2 minutes. The engines continued to burn, strong, controlled. Someone whispered, "Keep going." But the hardest part was coming. Reaching orbit was not easy. Many rockets fail near the end. Fuel runs out. Engines shut down too early or too late. 3 minutes. Stage separation was coming. This moment had destroyed rockets before. If it failed, the mission was over. The command was sent, separation. For a second there was nothing. Then it worked. The first stage separated cleanly. The second stage ignited perfectly. Some people covered their mouths. Others stared at the screens. No one celebrated, not yet. The rocket was now racing around Earth, but it was not in orbit yet. Orbit is a very specific place. Too slow and you fall back, too fast and you lose control. 4 minutes, 5 minutes. The engine burned steadily. Fuel levels dropped. Time was running out. Then it happened. The engine shut down, right on time. Silence. The longest silence of their lives. The computer checked the numbers, speed, altitude, trajectory. Then the words appeared on the screen: orbit achieved. For a second, no one reacted, as if the brain needed time to understand. Then the room exploded, not with fire, but with emotion. People shouted, people cried, people hugged, some fell into chairs, others stared at the screen, shaking. They had done it. SpaceX had reached orbit. This was not just a successful launch. This was survival. Phones started ringing. Emails arrived. NASA was watching. The world was watching now. SpaceX was no longer a joke. They were real, but this success came with a warning. One launch did not change space forever. It only opened the door. Reaching orbit once was not enough. To change space, SpaceX needed more launches, more reliability, more innovation, and most importantly, they needed to solve the biggest problem in space travel: cost. Because even now, rockets were still thrown away. Burned after one flight, still expensive, still wasteful. That night, while the world celebrated a new success story, SpaceX was already thinking ahead. They asked a dangerous question, a question no one else was brave enough to ask. What if rockets did not have to die? This question would change everything. But first they had to survive what came next, because success brings attention, and attention brings pressure. NASA would now expect results. The world would expect perfection. Failure would no longer be forgiven. SpaceX had won one battle, but the war had just begun. The rocket had reached orbit. The world saw success. But inside SpaceX, no one was relaxed, because they knew something important. This success was fragile. One good launch does not change the future. One engine does not create a revolution. Space is cruel. It does not forgive mistakes. While the world celebrated, SpaceX was already worried. Their rocket worked, but it was still too expensive, still too slow, still too normal. The real problem was not the rocket. The real problem was the engine. For decades, rocket engines were treated like magic. Only a few governments could build them. They were complex, expensive, and difficult to change. Most companies used old designs, small improvements, small changes, nothing risky. SpaceX did not want small. They wanted different. Inside a quiet room, a question was asked, a dangerous question. What if we build our own engine? This idea scared people not outside SpaceX. Inside SpaceX, building a rocket engine is one of the hardest things on Earth. The temperature inside is hotter than lava. The pressure can crush metal. One tiny mistake can destroy everything. Many experts said private companies should never try. They said buy engines. They said do not build them. They said you will fail. SpaceX listened and then ignored them. They believed something simple. If they could control the engine, they could control the future. The team started with nothing. No old factory, no secret designs, no experience building engines at this scale. Only computers, test stands, and a lot of courage. The engine needed a name. They called it Merlin. A simple name, but the engine was not simple. Merlin had one job: be powerful, be cheap, and one day be reusable. This was a problem. Most engines were powerful or cheap, not both. Reusable was almost impossible. Merlin had to survive extreme heat, then extreme cold, then heat again, over and over. Early tests were ugly. Engines exploded, metal cracked, valves failed. Sometimes the engine did not start, sometimes it did not stop. Both were dangerous. Each failure was loud, each failure was public. Videos of explosions spread online. People laughed again, but the team kept going. They changed one small thing at a time. They learned fast because they had no choice. Money was still limited. Every test mattered. Every failure hurt. The engine design was different from others. SpaceX removed anything unnecessary. Fewer parts, fewer pipes, fewer chances to fail. Simple does not mean easy. Simple means careful. The Merlin engine slowly improved. It became stronger, more reliable, more controllable. But there was a secret challenge. One problem no one talked about. Merlin was not just for launch, it was also for landing. Yes, landing. Most rockets never think about coming back. They burn until empty. Then they die. SpaceX wanted something else. They wanted the engine to restart in the air after launch. This was dangerous. Restarting an engine mid-flight is risky. Doing it perfectly is rare. The team tested again and again and again. Sometimes the engine restarted. Sometimes it did not. Each failure added fear, but each success added belief. At the same time, pressure was increasing. NASA wanted results, contracts were coming, deadlines were real. SpaceX could not hide anymore. They had to deliver. Then came a meeting, a quiet meeting, one that changed everything. Someone asked, if Merlin works so well, why do we still throw it away? The room went silent. Everyone knew the answer. Because landing rockets was insane. Because no one had done it. Because failure would be very public. But SpaceX was built on insane ideas. They imagined a rocket slowing down, turning around, landing on Earth, standing upright. It sounded like science fiction. The engine would need perfect control, perfect timing, perfect reliability. Merlin was not ready, not yet, but SpaceX decided to push it further. They had to. They tested the engine beyond limits. Hotter, longer, harder. They broke engines on purpose, to learn, to improve. Slowly, Merlin became something new, not just an engine, a tool, a system, a future. But the biggest test was still ahead, not in a lab, not on a stand, in the sky. The next launch would not just go up, it would try something never done before. The engine would shut down, then restart, then fight gravity. One mistake, and the rocket would be lost. The world did not know yet. But SpaceX was about to attempt the impossible. And if Merlin failed, the dream of reusable rockets would die because everything depended on this engine. In the next part, SpaceX would take its biggest risk yet, not to reach space, but to come back. The rocket did not explode, at least not yet. It climbed into the sky like always. Fire pushed it upward, noise shook the ground. To the world this looked normal, but inside SpaceX this launch was different. Very different. This time SpaceX was not only watching the rocket go up, they were watching it come back. For most rockets, the story ends after launch. Fuel burns out, the engine stops, the rocket disappears, but SpaceX was asking the rocket to do something insane: turn around. After the rocket reached space, the first stage separated. Normally this is where it dies, falls into the ocean, breaks apart, is forgotten. But this rocket did not want to die. High above Earth, the first stage was now falling. No engine firing, no control, just gravity pulling it down fast. At this speed, even air becomes dangerous. The rocket began to shake, heat increased, pressure built. Inside SpaceX no one spoke. They knew what was coming. The hardest part. The command was sent: restart the engine. This had never been done like this before. An engine restarting while falling from space. One mistake and the rocket would tear itself apart. Seconds passed, nothing happened, then suddenly fire. The engine came back to life. For a moment the rocket slowed, cheers almost started, but they stopped too early. The rocket was still falling, still fast, still unstable. Guidance systems worked non-stop. Small movements, tiny corrections, every calculation mattered. But space does not care about effort, only results. As the rocket entered thicker air, everything became worse. The shaking increased, heat wrapped around the metal body. One sensor failed, then another. Inside the control room, faces turned pale. They had seen this before. This was how rockets die. The engine tried to fire again, but it was too late. The rocket began to spin, not fast, slow, deadly slow. There was no explosion, no big fireball, just loss. The signal disappeared. Silence filled the room. The rocket had failed to land. It fell into the ocean. Broken, gone. Outside SpaceX, people reacted quickly. Headlines appeared. SpaceX fails again. Landing rockets is impossible. Science fiction, not science. The laughter returned, the doubt returned. Inside SpaceX, the mood was heavy. This failure hurt more than others because this time they were close, very close. Some people asked the hard question: is this worth it? Landing rockets cost time, cost money, cost reputation. They could stop. They could return to normal launches. They could survive without landing. But survival was not the goal, change was. The team watched the data again, frame by frame, second by second. They saw where it went wrong, tiny errors, small delays, one decision too late, fixable problems. This gave them hope. They tried again, another launch, another landing attempt. The rocket fell, the engine fired, the rocket slowed, then crashed. This time it hit the ocean hard. Metal shattered. Fire spread across the water, failure again. The internet exploded, memes spread, people mocked. Just give up. This will never work, stop wasting money. But SpaceX did not stop. They learned, they adjusted, they improved. A third attempt, the rocket fell, the engine fired, the rocket slowed, the legs deployed. For a moment it looked perfect. Then the rocket tipped slowly, helplessly, and fell over. Another failure. This one was painful because it almost worked. Inside SpaceX, emotions were mixed. Hope, frustration, exhaustion, but something had changed. The rocket did not explode in the air. It did not lose control early. It reached the ground. That meant one thing: they were getting closer, very close. The engineers pushed harder, more tests, more simulations, more risks. They strengthened the landing legs, improved engine control, adjusted fuel timing. Failure was no longer a wall, it was a guide. Then came another attempt. This time the landing target was not land. It was a ship, floating, moving in the ocean. This was even harder. The ship moved with waves. Wind pushed the rocket, timing had to be perfect. Many thought this was madness. Landing on land was hard enough. Why make it worse? Because the future needed it. The rocket fell again. The engine fired again. Everyone held their breath. The rocket slowed. The ship grew larger. The legs deployed. Touchdown. For half a second it stood. Then explosion. Fuel leaked. Fire spread. The rocket collapsed. Failure again, but this time no one laughed inside SpaceX because they had seen something new. The first time the rocket touched the target, it almost stayed upright. That was enough. The dream was real. The world still doubted, but SpaceX did not. They were no longer asking if it could work. They were asking when, and that answer was coming soon. In the next part, SpaceX would face the moment that would shock the world. The moment when a falling rocket would finally stand tall. And when fire would turn into history. No one cheered anymore. Not because they did not care, but because they were afraid to believe. SpaceX had failed too many times. Every landing attempt ended the same way. Fire, metal, silence. This time felt different, but so did the others. The rocket stood on the launch pad, tall and quiet. It looked calm, as if it did not know what it was about to do. Inside SpaceX, the team was ready, not excited. Ready. They had fixed hundreds of small problems: fuel timing, engine control, landing legs, software. Nothing big, just everything. The plan was simple: go up, deliver the payload, come back, land. Simple on paper, impossible in reality. The launch was clean. The rocket rose into the sky. Fire and sound filled the air. Everyone watched closely. They had learned not to relax. Stage separation happened. The upper stage continued to space. The first stage began its fall. This was the moment that had defeated them again and again. High above Earth, the rocket turned, not randomly, carefully. Cold gas thrusters pushed it into position. It faced the planet again like it was looking home. Then gravity took control. The rocket fell faster. Inside SpaceX, screens showed speed numbers rising. Too fast, too dangerous. The command was sent: engine restart. Fire burst from the engine. The rocket slowed, not enough. It kept falling. The ocean was below, waiting. The engine shut down, then restarted again. Perfect timing. The rocket was now fighting gravity, pushing against Earth. The landing legs deployed, metal arms locking into place. No turning back now. The ground came closer. Seconds felt like minutes. Wind pushed the rocket sideways. Software corrected it. Fuel was almost gone. There was no extra, no safety. Just precision. 5 seconds, 4, 3. The engine fired one last time, soft, controlled. The rocket touched the ground. For a moment nothing happened. It stood straight, still, alive. Then the control room exploded. People shouted, people cried, people fell to their knees. Some covered their faces, others hugged anyone near them. Years of failure ended in silence, followed by joy. The rocket was standing like a tower, like a dream. This was not luck. This was learning. Cameras captured everything. The world watched in shock. A rocket had landed, vertically controlled, reusable. This had never happened before, not like this, not fully, not clean. Space changed that day, but SpaceX did not stop. They did not celebrate for long because one landing was not enough. One success does not change an industry. They needed consistency. They needed repeatability. They needed proof, so they did it again and again. Each landing improved. Each rocket came back cleaner, stronger, more confident. Soon something incredible happened. They reused a landed rocket. This was the real victory. The same engine, the same metal, the same rocket flying again. Costs dropped. Launch speed increased. Access to space expanded. Other companies panicked. Governments watched closely. The old rules were broken. Rockets were no longer disposable. They were machines, and SpaceX was not done. While the world celebrated landings, SpaceX looked ahead. Far ahead, they asked another dangerous question. What if Merlin is not enough? Because landing rockets was only step one. The future needed something bigger, stronger, more ambitious. Something built not just for Earth, but for another planet. A new engine was already taking shape, quietly, in secret. An engine that would make Merlin look small. Its name was Raptor, and it would change everything again. But building it would be harder, more dangerous, more controversial, and the risks would be higher than ever before. In the next part, SpaceX would leave safety behind and build the engine meant for Mars. The world thought SpaceX had won. Reusable rockets were landing, costs were falling. History was made. For most companies this would be enough, but SpaceX was not most companies. Inside SpaceX the celebration was short, very short, because they knew something uncomfortable. Merlin was reaching its limit. Merlin was powerful, reliable, proven, but Merlin was born for Earth and SpaceX was thinking about somewhere else. Mars is not friendly. It has thin air, extreme cold, long distances. Nothing about Mars is easy. If humans ever wanted to live there, they needed something new, not just a rocket, a system. Merlin could not do that. It was not designed for another planet. So SpaceX asked another dangerous question. What if we start again? Not improve Merlin, replace it. This idea shocked even SpaceX engineers. Starting a new engine from zero was risky, very risky. Merlin had taken years of pain, explosions, failures, learning. Why do it again? Because Mars demanded it. The new engine had impossible goals. It had to be more powerful than Merlin, more efficient, fully reusable, restartable, many times safe for humans, and there was one more strange choice. Fuel. Most rockets use kerosene or hydrogen. SpaceX chose something unexpected. Methane. Many experts were confused. Methane was not common. It was harder to store, harder to control. So why methane? Because Mars has methane. This was not an accident. SpaceX wanted an engine that could refuel on Mars. That meant rockets could come back. Earth to Mars, Mars to Earth. This engine was not just about travel, it was about survival. They named it Raptor. A sharp name, a dangerous name. Raptor would use something called full-flow stage combustion, very complex, very risky. Almost no one had made this work before. It pushed engines to their limits, extreme pressure, extreme heat. Many experts said it was too hard, too unstable, too dangerous. SpaceX ignored them again. Early Raptor tests were brutal. Engines shook violently, metal cracked, sensors failed. Sometimes the engine destroyed itself, sometimes the test stand did. Failures were not hidden, videos leaked. Explosions went viral, people laughed again. Here we go again. SpaceX never learns. Why break what already works? But SpaceX had learned something important. Failure was information. Each explosion taught them something. About materials, about cooling, about control. Raptor slowly improved, pressure increased, efficiency increased, power increased. Soon Raptor became the most powerful rocket engine SpaceX had ever built. But power was not enough. Raptor had to land. Landing with Raptor was harder than Merlin. The engine was stronger, more aggressive, less forgiving. Small mistakes became big disasters. Then came the next challenge. Starship. Starship was not a rocket. It was a monster, fully reusable, both stages. Massive, and it would use many Raptors. Not one, not two, dozens. Controlling many powerful engines together was chaos. One wrong engine, one wrong timing, and the whole vehicle could be lost. Starship tests began, and so did the failures. Explosions on the ground, explosions in the air, fire everywhere. Each test felt like disaster. People mocked again. Too big, too ambitious, too stupid. But SpaceX did not stop. They built faster, tested faster, failed faster. Each explosion was followed by another prototype. Better, stronger, smarter. Raptor engines improved quickly. They became more reliable, more controlled. Then something strange happened. Failures became quieter, less fire, more data, more control. Landings started to work, not perfectly, but better. The impossible engine was becoming real. SpaceX had not just built a new engine. They had changed how engines were built. Fast, open, aggressive. Raptor was no longer a dream. It was real, and its purpose was clear. Not satellites, not Earth orbit, but humans on another planet. The cost of space travel was falling again, dramatically. Mars no longer felt impossible, just difficult, but danger was still everywhere. One major failure could stop everything. Public trust was fragile. Governments were watching. The future balanced on fire and steel. In the next part, SpaceX would face the biggest test yet. Not just engines, not just rockets, but Starship. The vehicle that would decide whether humanity stays on Earth or becomes a multi-planet species. Starship did not look normal. It was too big, too shiny, too strange. It looked like something from the future or a mistake. People were confused. This is a rocket. It looks like a building. Why stainless steel? Starship was not designed to be safe. It was designed to be possible. SpaceX wanted one thing: total reuse. No parts left behind, both stages, the booster, the ship, everything coming back. No company had tried this before because failure would be massive. Starship needed many Raptor engines, too many, each engine powerful on its own. Together they were chaos. Controlling them was like balancing fire. The first Starship tests were small, short hops. Low altitude, even these were dangerous. Engines shut down early, vehicles tipped. Fireballs filled the sky, cameras caught everything, the internet exploded, people joked. Another SpaceX explosion. This is getting embarrassing. They should stop, but SpaceX was learning. Every crash was planned, every failure was expected. Then came the big tests, high-altitude flights. Starship would climb high, cut engines, fall, turn, restart engines, land on paper. It was beautiful. In reality, it was brutal. The first attempt climbed perfectly. The fall began, the flip maneuver started, then engines failed. Starship hit the ground, exploded, failure. The second attempt was better, higher, more controlled, but again engine trouble, explosion. Critics grew louder, media headlines turned harsh. Out of control, too dangerous, wasting resources. Governments watched closely, environmental groups protested. Regulators delayed launches. Pressure grew from all sides, but SpaceX refused to slow down. They believed speed was survival. Prototype after prototype was built. Each one improved, small changes, big impact. Then came a flight that shocked everyone. Starship climbed, fell, flipped, engines reignited, it landed perfectly. For the first time, the impossible worked. Cheers erupted, not just inside SpaceX, around the world. But success brought a new challenge. Scale. Starship was not meant for small hops, it was meant for orbit. That required a new monster, super heavy, the biggest rocket booster ever built. Dozens of engines, unimaginable power. A single mistake here would not be small, it would be historic. The first full stack test began. Starship on top, super heavy below, engines ignited, the ground shook, windows rattled miles away. The rocket rose, slowly, powerfully. For a moment it looked unstoppable. Then engines failed. The rocket lost control, it was destroyed midair, explosion visible for miles, debris fell into the ocean. The internet went wild. Disaster, failure, end of Starship, but SpaceX saw something else. Data: the rocket had lifted, engines had worked. The structure survived extreme forces. This was not the end, this was the beginning. They fixed problems, improved engines, improved separation, improved control. Another test, more success. More failures, but each time Starship went further. The most dangerous rocket was slowly becoming real. The world now understood this was not about launches, not about money. This was about changing humanity's future. And the final question remained: could SpaceX make Starship reliable? Could they make it safe? Could they make it human-ready? The answer would decide everything. In the final part, SpaceX would face the ultimate challenge, turning a dangerous experiment into the future of space travel. The explosion slowly stopped. Not because the danger was gone, but because SpaceX had learned enough to move forward. Starship was still risky, still unfinished, still controversial, but something had changed. People were no longer asking, why is SpaceX doing this? They were asking, how far will they go? For decades, space had been controlled by fear. Fear of failure, fear of cost, fear of change. Governments moved slowly. Companies played safe. Innovation waited for permission. SpaceX broke that pattern. They did not wait to be perfect. They tested early. They failed loudly. They learned fast. This approach shocked the world. Some called it reckless, others called it genius. But one thing was clear: space was no longer frozen in time. Reusable rockets were now normal. Landing boosters became expected. Launch prices dropped again and again. What was once impossible became routine. Satellites launched faster. Small companies entered space. New ideas were born. The space industry woke up. Other companies followed, governments changed plans, competition returned to space. This was SpaceX's real victory. Not one rocket, not one engine, but change. Engines like Merlin and Raptor were not just machines, they were statements. Statements that said, space does not belong to the past. Reusable engines meant less waste, less cost, more access. Suddenly, space was not just for superpowers, it was for startups, scientists, dreamers. And then came Starship. Starship was not perfect, it still exploded, still failed, still scared people, but Starship represented something bigger. A future where humans are not trapped on one planet. Mars was no longer science fiction, it became a serious plan. Starship could carry people, cargo, entire cities in pieces. The idea was bold, dangerous, necessary, because history has shown one thing: staying in one place is risky. Earth is fragile, civilizations rise, civilizations fall. SpaceX believed humanity needed a backup, not to escape Earth, but to protect the future. Critics remained. They warned about safety, environment, costs. These concerns were real, and SpaceX did not deny them. Instead, they worked. Improved design, stronger materials, better engines. Progress was slow but steady. The biggest change was not technology, it was mindset. Failure was no longer the end, it became part of the process. Young engineers watched and learned. New companies copied the model. Fast testing, fast learning, fast improvement. Space exploration entered a new era, an era where courage mattered more than comfort. Today, rockets land like clockwork. Engines fly again and again. Launches happen weekly. What once took decades now takes years. SpaceX did not do this alone, but they started it. They reminded the world of something important. Progress is not safe. It is risky, messy, uncomfortable, but without it, nothing changes. From a desperate call to a standing rocket to a vision beyond Earth, SpaceX rewrote the rules. They showed that small teams can challenge giants, that private companies can change history, that impossible ideas can become normal. The story is not finished. Starship will fail again. Engines will break, plans will change. But that is not the end, because SpaceX never promised perfection. They promised effort, and effort over time changes everything. Somewhere in the future, a human will look at Earth from another planet. And when they do, they will stand on engines born from fire, built from failure, driven by belief. That is how SpaceX reinvented the rocket engine, not by avoiding mistakes, but by refusing to stop.